So for unit 2, yeah. Okay, so I'll have to print some more out of those. I'll make some more copies. So for unit 2, we had gone over a variety of different things. There was a lot in unit 2. Let's talk through some of the different ways of describing different parts of the graph. So like for part A, state the open interval on which f is increasing. If I'm looking through this, do you see any sections of the graph where f is increasing? How would you describe where the graph is increasing? Michael, go for it.
5?
Say again?
Wait, 3 to 5?
3 to 5, so we've got it increasing here. Anywhere else where the graph is increasing? 2 to 3. Now, for those two, does everyone say that it connects, right? And it doesn't stop increasing? It's actually increasing the whole time? 1 second. Yes, I'll see if I have an extra one. So, for that little section, then, I would actually state that this is increasing all the way from 2 to 5 the whole time. And when we do open intervals, we usually show it like this. We use parentheses because at 2 and at 5, it's not increasing or decreasing. It's changing right there. So again, open intervals always with parentheses. We're talking about x values for these open intervals, so like from here to here. So the same thing's going to happen when we talk about decreasing. Anybody see a section of the graph that's decreasing? 1 to 2. So we've got one little piece right here. This section is decreasing. Anywhere else where it's decreasing? 5 to 9. Is everybody good there? We could also have sections where it was constant. They don't actually ask us for that, but that would be -4 to 1. That section would be constant. Now for C, it says state the domain and range. So the domain here, what's the farthest left that this graph goes? We agree we're starting over here at -4. And we go all the way to 9. Now, with that, domains and ranges are different than open intervals. I have -4 and 9 on my graph, so I'm going to put those with brackets to show that both of those are included. Again, different than the open intervals. The range, what's the lowest value that this graph has? Right, we're on the x-axis at 0. And then we go all the way up. What's the highest that we get? I agree we get up to 3. And both of those are also included here. So you can put little brackets on those. 0 to 3. Letter D, state the coordinates of any relative minimums. Do you see any minimums up here? Relative minimums. 2, okay, careful, 2, 0, right? That point right there would be at 2, 0. In order to be a relative minimum, it's got to be decreasing to increasing. That's the only place where my graph goes decreasing to increasing. Remember that relative minimums and maximums cannot be on constant portions of the graph. They can't be where the graph is straight. They also can't be on the ends, the beginning or the end. So it's got to be decreasing to increasing. There's only one spot that happens here. How about relative maximums? 5, 3. This is the only place where it's increasing to decreasing. So that would be our relative maximum. The test might ask you to identify them like that. It might ask you how many there are. Anything like that. It might ask you, like, between this number and this number, is there a relative maximum? You can say yes or no. So, variety of ways to answer or to ask that question, but the idea is, can you identify those relative minimums or maximums? Now, the last part of this question is definitely the longest. We need to find a piecewise defined function. If I want to write a piecewise defined function, we say f of x is equal to, and we put some brackets here, or a big bracket to say, okay, this is my group of functions or group of pieces to make my piecewise defined function. The first one's easy, right? The equation of the horizontal line is just 2. It's 2 the whole time. Is everybody good with that? Horizontal lines are just a single number. The next piece is where it gets a little tricky. This is a quadratic. And that quadratic,
It's good. Yeah.
go for it.
So what if it's like a straight line, but like going this way?
So if it's diagonal, you'd find either a point on the line for HK and then a slope, or if it's up and down.
Yeah, up and down.
Okay, it cannot be a vertical line because then it's not a function. Because a function has, for every x value, one y value. And a vertical line, that one x value has an infinite number of y values. So I'll never have a piecewise defined function with a vertical line in it. Does that idea make sense?
Yes.
So it won't happen. But if we were graphing just that line by itself, not a function or anything like that, then it's x equals instead of y equals. So here, this one is f of x, which it means y equals 2. That's a horizontal line. We've got the equations up there, same ones we were using on Friday. I know that it's a quadratic, so y equals a, x minus h squared plus k, and I know it's a quadratic because of that U shape in the graph. Can everybody identify the vertex? We got 2, 0. That's my vertex, so I could put that in. Y is equal to a times x minus 2 squared plus 0, which really isn't going to do anything for my graph, but we'll put it there anyways for now. And then the last piece here, I need to find a, the last piece of this particular part. In order to find a, I need to plug in another section of the graph, another point. So let's take this one. That point right there is 3, 2. And if I plug that in, 2 for y, 3 for x, 2 is equal to a times 3 minus 2 squared plus 0. And I'm just going to solve for a. 3 minus 2 is 1, so I get like 2 equals a times 1 squared. A times 1 squared is just a, right? Multiplying by 1 twice. So 2 equals a. So my actual equation then is 2 for a, x minus 2 squared, and I could put a plus 0, but why? I don't really need it. Plus 0 is not going to do anything for me. If you put it, it's not wrong, but you probably won't see it on the test. And the third piece, I'm going to get to that, yes. It's second period, I did it like I'm doing it here. Third period, I did that part first, then came back. You can do it in whatever order you want, but yes, we're going to get to that. So the third piece here is the absolute value, which is a little bit easier. Y equals a x minus h in absolute values plus k using the vertex. So the vertex here is 5, 3. So I'm going to plug that in. Absolute value, x minus 5 plus 3. But I still need to get the a value. The trick is I don't have to do all this solving like I did here for the quadratic. I can just count the slope. Since it's straight lines, I'm going down 1 over, looks like 2. Down 1 over 2. Down 1 back 2. Yeah, pretty sure the slope here is negative 1 over 2. Now, why is it negative 1 over 2? Right, the whole graph's going down on both sides. So negative 1 over 2. And then we had a question up here. Does everybody remember that there's supposed to be more to this? I have to describe where that's happening. Not just the 3 graphs, but where each one happens. So the horizontal line is happening from negative 4 to 1. So I'm going to put this as 2 with negative 4 less than or equal to x less than or equal to 1. The next one, try to make this clear here. 2 times x minus 2 squared. That one is happening from 1 to 3. Right here. From 1 to 3. Negative 1, or sorry, positive 1, less than x, less than or equal to 3. Now, why didn't I put an or equal to on that one? Go for it.
Because the other one already has an equal to.
Right, I already put it on here. These are the same point. Yes, they share that point, like they meet right there, but I have to pick one to give it to, because they can't both have it at the same time. So I already put it here. You could put it here, it just can't be on both. Last one is happening from 3 to 9. So 3 less than x less than or equal to 9. There is my three-pieced, piecewise defined function. Now again, you won't have to do that from scratch. It's multiple choice. So it might be, here's the equation, and you look at the different graphs, see which one's correct. It might be that they're just going to ask you for one piece of it. But again, as long as you can make that connection, as long as you understand where these pieces came from, it should be good when we get to the test. Any questions with number 1 there? All right, then let's look at number 2. There are an oddly high number of absolute value questions on the test. Okay? So you want to make sure that these make sense and that you're able to do these. Both 2 through 5 here, where it's an equation, and 6 through, I think it's 6 through 9 on the next page, where it's inequalities. You need to be able to do both. Okay? So I'm going to do number 4 for you guys right now. Then I'm going to have you guys try number 2. And then we're going to talk through 3 and 5. 3 and 5 are special cases. 2 and 4 are the most normal as far as typical ones to solve. Can anybody tell me how to get rid of that 2 over 5? Because I need the absolute value by itself. So Adrian's been answering a lot. Anybody else want to help us out here? Go for it, Michael.
By 5 on both sides.
So that would be a good start. Yes, we can multiply by 5 on both sides. Is there a way to do this all as one step? Or what were you going to say?
I was going to say multiply by the reciprocal one.
Right, so instead of just 5, do 5 over 2. Go ahead. Does that make sense? So what Michael was saying would have been just fine. You multiply both sides by 5. You just have to divide by 2 after that. Whereas if we multiply both sides by 5 over 2 right now, we get the whole fraction simplifying to 1, leaving us with absolute value 3x plus 2 is equal to, here 20 times 5 divided by 2. 20 times 5 would be 100. 100 divided by 2 would be 50. And again, you can just put that in the calculator. You could do 20 times 5 divided by 2, you'd get that 50. So now, once the absolute value is by itself, then we can go ahead and split it into 2 separate equations. One to show what would happen if the inside was equal to 50. If the inside is equal to 50, the absolute value does nothing. So 3x plus 2 equals 50. Or the inside could be equal to negative 50. If the inside is equal to negative 50, then the absolute value makes it positive 50 and we're good again. Still equal to 50. We solve both of these on their own. So that means subtracting 2 from both sides here. 3x equals 48. Divide by 3. X is equal to 48 divided by 3 is 16. There's my answer. But that's only half my answer. I needed the other half. So for the other one, subtract 2. It's the same kind of steps, but I'm going to end up with a different answer. 3x equals negative 52. And here, when I divide by 3, it does not work out nicely. I end up with just, really, negative 52 over 3. So on the test, you might have multiple choice answers. It might be like couple with 16, couple with the negative 52 over 3, but some of them might be negative 16, or they might be positive 52 over 3. Or maybe they say, well, that's about 17. But no, we want the exact answers here. So you're looking for the one that has both of these. Does anyone have any questions on that one? What if you blank and you don't remember how to split this up, come up with 2 answers? How do you check, like, is there a way for me to just know if I have these 2, is there a way for me to see if they're the right answers? Is there a way for me to tell if these 2 are solutions to this original one? Actually, I'm going to have, yeah. Does that make sense to everybody? You can plug in the points, and if it works, so if I put 16 in, 3 times 16 is 48, plus 2 is 50, 50 times 2/5 is 20. So it works. And I should get the same thing if I put in negative 52 over 3. Both of these should work. It should be the only 2 that work. So if you plug in something on one of the options and it doesn't work, it's not the answer. I want everybody to try number 2 right now. Everybody try number 2. If you finish that one quickly, tell me why 3 is no solution. So if you've got time, you can look at number 3 and tell me why that one's no solution. you have questions though, let me know.
I like this weather. I wish it was like this weather.
The ones I have, so I mean, the ones I have are the exact same ones that you have.
They're the same ones.
That's all I have. They just emailed us saying that the ones down here are unlocked. So you should be able to go there just take that with you.
I think you meant for number 3, you should get.
Yeah. You would subtract the 1 first because you're getting that absolute value by itself. Subtract the 1 first because the absolute value by itself is then the addition to the equation. Yeah, there's Wait.
Yeah, I just want to find that.
Who still needs a copy of the Unit 1 review? I know there were 1 or 2 of you in here. Who did not get a Unit 1 review? All right, let's go over it. Hopefully that was enough time for most of you to get through. So for number 2 here, what is our first step? We need to get that absolute value by itself. So how do I go about doing that? Yep, we're going to subtract the 1 from both sides. Gets us the absolute value of 3x plus 2 equal to 11. So, Aaliyah, can you give me one of the 2 where... There you are. One of the 2 equations that this would end up being. So we're going to split it into 2. Can you give me one of those? Yep, 3x plus 2 equals 11. One just without the absolute values. And then the other one, a little bit more complicated. Abby, do you have the other one? The other equation. So we split this into 2. We have one where it's just no absolute values. Do you remember how we changed the second one? Exactly. 3x plus 2 equals negative 11. Those are the 2 that we're solving. Let's jump. I'm assuming most of you can subtract 2, divide by 3. What are the 2 answers then? Jackson, did you get one of the 2 answers? So if you don't have it yet, go ahead and finish solving this one. Solve that for x, and I'll get someone to do the other one. Victor, do you have the answer for the other one? This one didn't work out quite as nicely. Or are you still working on that one?
That would be 13. Oh, I got this one.
It ends up being negative 13,
13.
but it's still 3x, so you still need to divide by 3 here.
3x and then divide 13 3.
Yeah, and it actually doesn't, oops, I wrote 2. It doesn't. So that's actually how you should probably leave it. Negative 13 over 3. And then, Jackson, as soon as you get that answer for the other one, go ahead and shout it out.
3.
Yep, x equals 3. So you get 2 answers there. One nice whole number, one a fraction. That's pretty typical. Those are your 2 answers that would both work for this. And again, you could plug them back in. They should work. The fraction's a little bit harder to work back out, but it will still give you the correct answer. Now, number 3 has a little issue with it. In order to get the absolute value by itself, I need to multiply both sides or divide both sides by negative 1.
Wait, hold on. I thought you said that number 2 was like no solution.
No, I said number 3 was no solution. And this is the one that we're going to talk about. So if I multiply both sides by negative 1 or divide both sides by negative 1 to get the absolute value by itself, x over absolute value of x over 2 minus 5 equals negative 4. Anybody think they can describe why this one is no solution?
There can be 2 negatives.
So it's not the 2 negatives. It is related to the negative. Chris, go ahead. Absolute values can't equal negative numbers. They're always going to be positive. And so anything along that line, it says if there is no solution, write none, and then explain. So absolute values cannot equal negative numbers would be fine.
Answer number 5.
So I am actually going to leave number 5 for you guys to do on your own. So if you've already done it, you're great. You're ahead. So the first step, actually, you can give us a hint for the first one, because I did that with the other classes. So Michael, if I divide both sides by 3, what do you end up with?
0 over 3.
Right, and that's still just 0, right? So you can still solve this one. Just know that you're going to get the same answer for both of your equations, because 0 and negative 0 are the same. But I'm not going to do that one right now, because I think you all can finish that one. If you have questions, let me know. But let's look at the inequalities on the next page. These are very similar to what we were just doing. I'm going to work out number 7 for you, and then I'm going to have you guys do number 6. So number 7, same idea. I still have to get the absolute value by itself. And so to do that, I'm going to divide both sides by negative 2. Divide by negative 2. Absolute value of x plus 1 is, here's the trick. I divided by a negative. Anybody remember what extra step I have to do when I do this? Go for it, Aaliyah. Flip the sign. So this is going to be greater than positive 5. And now I'm still going to make 2 equations. X plus 1 greater than 5. Greater, we said, was or x plus 1 less than negative 5. So we're kind of guessing again. I'm going to get numbers that are, or essentially these 2 sets going away from each other. One where everything is bigger than 5, one where everything is less than negative 5. But they're not actually solved for x yet, so I can subtract 1. X is greater than or on the other one, subtract 1. X is less than negative 6. Now this one says don't just solve, but write your answer in in interval notation and graph it on a number line. So to graph it on a number line, here's 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So we've got those. So now I can go ahead and put open circles on both of those. And I'm going above 4. Now, why open circle? Because it's not or equal to. We're not including those endpoints. Same thing down here. Open circle, less than 6. And then the way I write this, as far as interval notation, would be negative infinity to negative 6 with a parenthesis, and then 4 to infinity. Negative infinity to negative 6, 4 to infinity. That would be my solution set in interval notation. 8 and 9 are again kind of special cases. You can look at those, but I want you to do number 6 right now. Get the answer as best you can, show your work, graph it on a number line, write the interval notation, and give you like 3 minutes here to do those. Or that one. And if you're stuck, raise your hand and let me know.
There's someone like making shows on this one.
Apparently they've been having major issues with the bathrooms, which has been a pain for everyone. So I don't know how they're trying to keep this.
This is definitely. Oh wait, no. I want to finish the show. But like. Yes. That's okay.
So it'd be 3x greater than or equal. Okay. So you don't switch this sign. You didn't multiply or divide. You just added. The only time this sign switches directions to was greater than, it's going to stay greater than. You're just adding it back. The only time you switch signs is when you multiply or divide by a negative. Just rip them off. That makes sense. Divided by 3 is going to be a fraction. Yeah, not going to be nice. That's okay. Yes.
How about sushi instead?
What do you expect?
Okay. So the only time this switch.
What?
Okay, so when you rewrite your equation, the one that gets the negative, that sign has the equation. So you always have one of each in your solve. And then they don't switch again unless you multiply or divide by a negative number on both sides. Yeah, this one will end up being a fraction.
Is this right? Or some?
Yes, that is correct.
Oh, lady.
That's exactly right. All right, let's go over that one. So for number 6, is everybody good with the absolute value is already by itself? So when the absolute value is by itself, we can go ahead and split these into 2. And again, guys, keep your masks on. So here we've got 3x minus 10 less than or equal to 2. Less than should be an and. 3x minus 10 greater than or equal to negative 2. So you wanted the second one, flip the sign around, switch the direction of the arrow, and then we're going to solve both of these. So you should always, and this is again, this was like 3 months ago, so let's remember, when we're setting this up, we always have Okay, let's think about it like this real fast. Let's say I have the absolute value of x is less than 5. Give me some numbers that are less than 5. 4, 3, 2, all those would work. Does that make sense? But some negative ones work also, right? -1, -2, -3, those are all good. But what about -10?
Yes.
If I put -10 in here, the absolute value makes it positive. Is 10 less than 5? So I want both x's that are less than 5 and x's that are greater than -5. The opposite direction. So -4 is good, -3 is good, -2 is good, but not -6 or -7 or -8. So when we switch that, when we make the second one, not only do I make what it's comparing to negative now, saying, okay, the absolute value would take care of that negative, but I also need to flip the sign around because, well, -8 is smaller than -5, +8 is bigger than +5. It's the opposite direction when you switch that sign around. Does that make sense? So, you don't have to know that conceptual fact as long as you remember that it switches direction, but that's why it switches direction. So here, we've got 2, one with a less than, one with a greater than. You always have one of each. Then we can solve these. One of them works out really nicely. If I add 10 to both sides, 3x less than or equal to 12, I can divide by 3. This one works out to be a nice x is less than or equal to 4. The other one, though, does not work out quite so nicely. This one, we add 10 to both sides in the same way. But now I get 3x is greater than or equal to negative or +8. Can divide both sides by 3. And I get x is greater than or equal to 8/3. So now when I graph that on a number line, here's 0, 1, 2, 3, 4. -8/3 is going to be like a little bit above 2, but not quite to 3. -8/3 or +8/3, not -8/3, +8/3. So I've got a point here less than 4, point here greater than 8/3, and that would be my answer on the graph, just that little section between 8/3 and 4, which means my interval notation is 8/3 to 4 with square brackets because of the or equal to signs. Square brackets means include those endpoints, which is why they're filled in instead of open circles. Any questions on 6 and 7? Yes. Yes, just sign out and take the pass. So number 8 here. For number 8, real quick, we're not going to finish, we don't have to finish this one. Is you have a question, Jackson?
No.
Okay. So I'm going to subtract 4 from both sides. 3, 2x over 3 minus 1. -2 minus 4 is -6. I can divide by 3 to get the absolute value by itself. But the issue is I have an absolute value, 2x over 3 minus 1, less than -6 over 3 would be -2. Now, it's not equal to, it's less than. Can the absolute value be less than a negative number? No. Absolute values are always positive. Positives are always bigger. So we're going to put none. That one's impossible. There is no solution. None because positives are always bigger than negatives. And absolute values are always positive. There's many ways that you could explain this. The idea is, though, to explain that this does not work. That there's not going to be anything that's ever going to be a true solution for this. And absolute values are always positive. And we have the opposite issue for number 9. I subtract 2 from both sides. And divide by 2. Absolute value, x minus 5, minus 5, is greater than or equal to negative 1. Are absolute values ever greater than negatives?
Oh.
Yes, always. Does that make sense to everyone? That's always going to be true no matter what number you put in. So we're just going to put either all real numbers or infinitely many solutions. Technically, I think the all real numbers is a better answer here. All real numbers is probably best for this one. So you will also see it written as negative infinity to positive infinity. All real numbers.
You have to do the line graph for that one too.
So for this one, if you're going to do the line graph, you would shade in the entire thing. Does that make sense? Just everything on that line is a potential solution. Everything that you'd put in would work. Now, real fast, in our last 8 minutes here, which we'll be able to get just right where the other classes were as well. Number 10, list all the labeled points that are solutions for g of x equals 0. This is the whole, you're reading the graph, here's g of x. G of x equals 0 is the x-intercepts. So it looks like C. That's the only point. There's actually 3 x-intercepts, but only one of them is labeled. So we only put C. Does anyone have questions about finding where g of x equals f of x, or where x equals 0? This is a y-intercept, right? X equals 0 is a y-intercept. And then at the bottom, D and E, you're showing which points are above one graph on the other one, or below one graph on the other one. Does anyone have questions on number 10, or do you think you could do that tonight on your own? Okay. So if you come up with questions, you can ask them tomorrow. But let's look at this second, or the front of the next page. We're just going to get through the bottom of this page, and then the last page we're going to save for tomorrow. First one's 11a. Remember, if I'm comparing f of x equals g of x, and I've got a bunch of points, I can see where they switch places. If f of x is equal to g of x, which is what we're looking for, at the beginning, f of x is bigger than g of x. So I put f of x on top, g of x on the bottom. But then 2 is smaller than 3. F of x becomes lower than g of x, and they switch places. And right there, because they switched places, I'm going to shade. Then I look at the next one at 2. 4 is above 2, so f of x is bigger again. G of x is down here. There we go. And then the last one for 3, 5 and negative 2. 5 is bigger, so f of x is on the top. G of x is on the bottom. They don't cross there. Does everybody remember doing these 3 months ago? All right. So I'm going to have you guys finish B and C later tonight for homework. The last one that we're going to look at here, 12, 13, and 14. These are shading inequalities. So if I'm going to graph like this equation, y is greater than x squared plus 1, I can plug in points. I could find the vertex. 0, 1 would be a good place to start. If I put in 1, 1 squared is 1, plus 1 is 2. If I put in 2, 2 squared is 4, plus 1 is 5. 1, 2, 3, 4, 5. And the mirror image points. So I end up with a dashed line right here. And I'd be shading up above it, right in here. Whereas the second one, y is less than 1 minus x squared, I would rewrite that. Y is less than negative x squared plus 1. So that I see, oh, this one has the same vertex. But now when I put in 1, 1 squared is 1, make it negative. Negative 1 plus 1 is 0. Put in 2, 2 squared is 4. Negative 4 plus 1 is negative 3. Same thing on the other side. And I get another dashed parabola going down this way. and it's less than, so it's shading down here. Do these two shaded regions overlap at all?
No,
So they share 1 point, but they're both dashed lines. And dashed lines aren't included, so there is no overlap on these two.
If it was a solid line, would it?
If they were a solid line, you'd have 1 point solution, right where they crossed, if they were both solid lines. Does that make sense? So your homework is to do the ones that we have not done up through 14. So finish number 5, number 10, and then 11, 12, and 14. Finish those. Tomorrow, I'll answer any questions you have from there, and then we'll do the back page here with a bunch of solving with quadratics and other stuff. Just a whole bunch of solving. We'll finish that tomorrow then.